Dear students, in this video we are going to see exercise 9.3 second Roman 11th subdivision. Evaluate the following integral using properties of integration. Now integral 0 to pi x into sine square of sin x plus cos square of cos x dx. Now let us consider the whole function. Okay, this function without x. Let us consider this function as f of x. Now according to this property, f of a minus x is equal to f of x. Though we have x into f of x. See, whenever you have x into the remaining term, if you have f of x, let us, if this particular condition satisfies, then we can remove that x in the integral, okay, in our resultant. Now let us take f of x, and the integral here is 0 to a, so f of pi minus x. Pi minus x means 180 minus theta lies in second quadrant, and in second quadrant your sign is positive. So sine of pi minus x is nothing but sine x. Now even in x place we have to substitute pi minus x here. Cos of pi minus x is nothing but in second quadrant cos is negative. So we will get minus cos x. But here I have written plus. It's because of this square. Okay, so square is for the whole term. So though we have minus cos x, because of the square it becomes positive only. So therefore f of a minus x, we are getting again same f of x only. So since this condition satisfies, we can remove the x in the integral. Okay, we can remove the x. A by 2. So a by 2 means if you have a, half of that. So what is the integral here? Pi. So pi by 2, half of that, integral 0 to pi, and f of x. So after removing x, the remaining function sine square of sine x, cos square of cos x dx. Now here, since 2 pi minus x is equal to f of x, so 2a, in case if it satisfies 2a minus x, 2a means 2 times of even our integral, 360 degrees. 360 degrees minus x lies in fourth quadrant. So in fourth quadrant sign is negative. Though sign is negative, because of square it becomes positive. And cos is anyway positive in the fourth quadrant. So this condition satisfies. You will get again f of x. So by using this condition, we can write this as 2 times of 0 to a. So though we have pi by 2 here, 2 times of 0 to a. So 2 times of 0 to half of whatever the integral that you have. So what is the integral that you have? The limit is pi. Half of that, 2a becomes a, means half of that. So 0 to pi by 2. Sine square of sine x, cos square of cos x by using this condition. Then we can cancel here this 2 and 2. So therefore we have pi integral 0 to pi by 2 sine square of sine x, cos square of cos x. Now here we can apply integral of 0 to a f of x is equal to integral of 0 to a f of a minus x condition, okay, dx. So this condition we can substitute here. So therefore in x place I am replacing x by a minus x. So a minus x means pi by 2 minus x in x place. So let us consider this condition as equation 1. Now x is replaced by pi by 2 minus x. Pi by 2 minus x means it lies in first quadrant. In first quadrant sine is positive, even cos is also positive. So you will get sine square of, since 90 degrees is there, sine changes to cos. Here cos changes to sine. Okay, so let us consider this as equation 2. Now after doing this, let's add 1 and 2 equations. If I add 1 and 2 equations, here we'll get I plus I, these two. I plus I will become 2i. Here also we have pi, here also we have pi, so you can take pi as common. The same integral 0 to pi by 2, here also we have 0 to pi by 2. So if we take the integral common, we can add sine square sine x plus cos square cos x plus sine square of cos x, cos square of sine x. Now if you see here, sine square of sine x and cos square of sine x, these two are same. So if these two are same, the angles is same, sine x, sine x. So this is like sine square theta plus cos square theta is nothing but 1. And also as we see here, cos square of cos x and sine square of cos x. So these two terms, this one and this one, both the angles are same, cos x angles. So sine square of sine square theta plus cos square theta, since both are same, that is also 1. So this is 1 and 1 plus 1 will become 2. Now 2 is constant, you can take 2 outside. So after taking 2 outside, you will get integral 0 to pi 1 dx. Integral 1 dx, we can cancel here 2 and 2. So I is equal to, in pi, integral 1 is nothing but x from limit 0 to pi by 2. Apply upper limit minus lower limit. So you will get I is equal to pi into pi, which is nothing but pi square by 2 is your final answer.